Hey everybody, it's Dr. Eric Balcouch. We're back for another edition of Thyroid Thursday. And today I'm taking another listener question and kind of whiteboarding it out for you. I think I've covered the connection between thyroid and cortisol, thyroid and adrenal previously, but if somebody's asking, it's worth having another discussion. But look at some of my other Thyroid Thursday videos and maybe some of the Thyroid Answers podcasts. So this person wanted to know, what's the connection between hypothyroidism and adrenal fatigue? And so there's a controversy as to what adrenal fatigue is. There's some people, especially in the functional integrative space, that the chronic stress leads to the thyroid or the adrenal gland no longer being able to generate cortisol. It just becomes too fatigued. And I don't know that actually really happens, okay? But it's, it's talked about a lot. So here's like a classic definition of adrenal fatigue. Chronic stress leads to an inability of the adrenal gland to make cortisol, resulting in symptoms like tiredness, fatigue, sleep issues, etc. And initially, it's thought that acute stress drives up cortisol. The cortisol then blocks T4 from getting into cells and T3 from getting into cells, and that causes us to be tired and fatigued. And I don't know how much of that occurs either, okay? But people talk about it a lot. So here's one of the things that happens. Definitely in acute situations, the adrenal gland definitely drives up some cortisol. It can also increase the production of something called catecholamines. And I've got a theory about this, and I don't know that it's all worked out yet, but just a theory. So something to talk about later. So as the acute stress, adrenal cortisol goes up. Why would the body increase cortisol? Well, if there's some type of danger response, one of the things that cortisol is going to do is going to stimulate some of those defense mechanisms, going to help increase an acute need for glucose, and it can have essentially an anti-inflammatory effect as well. So in time, when stress is chronic, the adrenal gland can no longer make cortisol, and people call that adrenal fatigue. Is that what's really happening? I don't know. How do we typically identify that somebody has adrenal fatigue? Well, if you go to a functional medicine practitioner, a functional health coach, if you go to maybe an integrative practitioner, they may do salivary cortisol, they may do urinary cortisol and tell you, hey, yeah, your urinary metabolites are low or your salivary cortisol is low, therefore you have adrenal fatigue. And that's how they get to this diagnosis, because they see it low on the urine test and you see it low on saliva. But then if you go to a GP, they'll run like a morning blood cortisol level, and your cortisol levels will probably be normal or high. And so how do we justify that somebody could have adrenal fatigue if the morning cortisol that your medical doctor may be running is normal? Or even when I run a morning cortisol, I see it all the time. The cortisol in the blood is normal or high, but the Dutch test or salivary test or whatever metabolite test you're doing to look at the free hormones, the cortisol in the urine, those things look a bit low. So I think there's a couple things that we have to consider. One, acute stress does increase cortisol. We know that. It can increase your catecholamines as well. And so those are some of your fight or flight hormones. Epinephrine, norepinephrine, these fit into that category. But when we have chronic stress going on, we have the cell danger, inflammatory process going on, we get a number of things that could drive hypothyroidism, which is a decreased production or decreased conversion of T4 to T3. And that's a lot of times, in my opinion, how hypothyroidism starts out. It doesn't start at the gland, it starts at the tissue level, because most people are experiencing signs and symptoms they associate with hypothyroidism long before they're often diagnosed. So we get this decreased conversion of T4 to T3 that's impacting some cells and tissues, maybe not all of them. And so the person's maybe they have some elevated lipids, maybe they have some signs and symptoms at the adrenal gland. And I'll talk about that more in a second. But we have this cellular hypothyroid state go on. And when we have tissue hypothyroidism, less T3 inside the tissues, and we often can see that as a low total T3, a low free T3, a low free T3 to free T4 conversion, then we're going to have reduced mitochondrial function. Now, is the reduced mitochondrial function the problem? Because a lot of people just say, hey, just take mitochondrial support products and that'll fix your mitochondria. I often look at mitochondrial down regulation as an adaptation, at least early on, not the problem. Because when cells perceive danger, that kicks in their cell danger physiology, and the mitochondria is a huge sensor of that. So when that happens, there's this whole change that goes on in the cell to slow down the metabolism and ramp up cell defense. And reduction of T4 to T3 conversion inside those cells and tissues is part of that process, a very important part. So when we get this cell stress response, we get downregulation of T4 to T3. That helps support the downregulation of mitochondrial function. And the problem with that is if we have decreased mitochondrial function, we have decrease in something called Krebs cycle or the citric acid cycle. We have downregulation of this electron transport chain, so we can make less ATP. So ATP is the currency for energy in the cell. We're typically eating food to convert it into ATP, cell energy. And when we have decreased ATP, this results in the increased circulation of something called adenosine. And adenosine is the base molecule, adenosine triphosphate. But as I pull off those phosphate groups and I'm left with more adenosine, adenosine is your sleep molecule. When adenosine binds to receptors, that's what makes us tired and sleepy. And this is why you're taking things like caffeine to block adenosine from binding to receptors so that your brain doesn't feel as tired and sleepy. But when you have more circulating adenosine because you don't make a lot of ATP and you're going to wind up with more circulating adenosine, you're going to have some chronic fatigue. You're going to be tired because this adenosine is constantly hitting your brain, telling you you're tired and you're fatigued. Now, your body will start to compensate for that, and that can be something like your catecholamines, your fight or flight hormones start kicking in to help, or you might start adding things to try and artificially stimulate brain to prevent it from feeling sleepy, but then that creates a potential problem as well. So as we have less T3 in the cell, we can have less cholesterol transport into the adrenal gland. So the adrenal gland, to make cortisol, it makes it in two ways. One, in acute stages, the adrenal gland can make its own cholesterol and then convert that into cortisol. The other thing that typically occurs is that the adrenal gland brings cholesterol from the bloodstream into the adrenal gland to make it into cortisol. And that's the bulk of the cortisol we get is from that mechanism. Now, to get cholesterol out of the bloodstream and into the adrenal gland, you need, guess what? You need T3. So if I have a low T3 state, guess what? I'm not going to be able to bring as much cholesterol into the adrenal gland to have it available to make into cortisol. The next step of once cholesterol is in the adrenal gland, it gets converted into something called pregnenolone in the mitochondria. But if I have a low T3 state, then I'm going to have reduced mitochondrial function, so I'm not going to be as efficient at converting cholesterol into pregnenolone and pregnenolone into cortisol. So these mechanisms can all contribute to the decreased cortisol production. But why would my blood cortisol be normal if my doctor checks my blood waking cortisol? Well, you have something called a cortisol awakening response. And remember, I said the adrenal gland can make its own cholesterol, and it does this many times in acute situations. And it's my thought process that this also is part of the cortisol awakening response, because it's this adaptive piece of our physiology that needs to occur. So even though somebody might have low urinary metabolites, lower saliva cortisol, the morning waking blood cortisol could be normal because they have this ability in acute situations. And I think the cortisol waking response is one of those where the adrenal gland is just making its own cholesterol to support cortisol, to support that our rising in the morning and the drive of cortisol in the blood to help us with this whole awakening response. So if we have decreased cortisol and we have decreased thyroid hormone, the combination of those two things, the body is probably going to compensate for energy production by increasing catecholamine. And this is where we can feel wired but tired, because our body's driving energy with these kind of fight or flight symptom or hormones that really drive the brain to be active, but the rest of the body's in crisis fatigue mode. And I think there's a concept, I haven't proven this out yet, but I think there's this thing I call tyrosine steal. And my wonder is, when we have this cell stress, cell danger thing going on, and we need to drive up catecholamines, are we stealing tyrosine from the thyroid gland to do that?